the cloud. Cool. Michael, do you wanna run the agenda for us?
Yeah, our first presenter, but he will present by the means of a video, prepared video, is Paul. And next is Danny. And if Conrad will join us, then he will be third and maybe last. Otherwise, Daniel will be our third presenter. So I'm really curious to what everybody will is going to show us. Ivan, will you handle the time?
Yes.
For the first.
Yes, I will. Let me get my chess clock open. All right, there we go. So yeah, it's just to remind everybody of the format, it's split 50-50 time for presenters and audience questions. So you have 7.5 minutes to present and then 7.5 minutes of questions. If you would like to adjust the balance of time, just say before you start presenting. And I guess in the case of this video, Paul, how long is the video?
I think it's 8 minutes.
Okay, great, cool.
Exactly.
It was
Cool.
a lot.
Yeah, I know the feeling. Cool. Yeah, so whenever you're ready, let's roll that beautiful bean footage, as they say.
Shall I start it for you, Paul? Is that okay?
Yes, please. Yes.
All right. Let's see if this will be fine. You see my screen?
Yes. Let's see if we can hear it.
Do you hear it?
Exploring techniques and notations for augmenting developer experience. This demo needs explanation, so I will present a few slides first. This demo is about how to create new notations instead of championing a single notation. We must stop believing that old-fashioned notations meant for printing presses are suitable for programming and reprogramming this new medium. We must use many programming languages and join them together into a workflow for program development. Documentation doesn't work. Documentation must generate code. Function-based notation is useful for programming calculators and computers. Function-based notation is stressed beyond its sweet spot for programming other kinds of things, like truly asynchronous actions. Function-based notation is based on mathematics notation instead of hardware CPUs. Alan Kay said that a computer is more than functions and sets. Hardware-centric perspective. We have become accustomed to a 1950s biased, mathematical, cost-cutting view of reprogrammable electronic machines. Using old-fashioned ideas from the 1950s, we are biased towards sharing memory and time-sharing CPUs. This causes accidental complexities and creates the need for workarounds. Originally, CPU ICs were designed to be non-reentrant and not to be thread-safe. The idea was to have networks of many hardware actors. But cost-cutting caused us to move away from those ideas. Cost-cutting forced us to use shared memory and to create development systems that needed extra software to fake out the function-based paradigm. In 2024, we can cease to cut these kinds of costs. We can waste machine power to create development workflows that are more like the model of hardware actors. The goal is to simplify DX, developer experience. I strongly believe that a simpler DX will lead to invention of simpler UXs for non-programmers. To work towards this goal, we need to explore many avenues of simplification. DAS, DOS, diagrams as syntax. 0D, extreme decoupling, zero dependencies. T2T, text-to-text transpilation. Detangling design intent from implementation. Studying smallness versus bloatware. Creating separate notations for software architecture, software engineering, and software production engineering. Replacing baggage due to the use of old-fashioned ideas. Failure-driven development. Coping with program development where programs have bugs and fail. We need to make it easy to wipe everything out and to start afresh as we learn about the problems we are trying to solve. We need to prevent calcification of design ideas that need to be revised, caused by the feeling of investment in partial solutions, caused by the notation we use. This demo will concentrate on only one kind of simplification, the idea of using different syntaxes for programming using current technologies. 0D is incorporated into this demo, but will not be detailed due to time limitations. Ask me or PM me for more detail. This demo implements a node and arrow diagrammatic programming language. Why? Node and arrow is simple. Node and arrow expresses sequential control flow and asynchronous control flow simply. Node and arrow is especially easy with 0D, yet node and arrow appears to be complicated when expressed in a function-based notation. This demo shows that switching notations can lead to more expressivity. It is easy to build node and arrow DPLs using existing technology, e.g. closures, queue objects. These are supported by all modern programming languages. Existing programming languages are but assembler for higher-level programming notations. Advances in technology make it easy to invent and implement new notations, unlike in the 1950s. Not shown, multiple inputs and outputs, feedback, connection directions, down, up, across, through. This is an implementation technique rather than advocacy for node and arrow. To my knowledge, all existing DPLs are based on synchronous implementation. This technique, in this demo, is fundamentally different. I bring up the stock draw.io editor. I close the general tab, open the 0D tab. I add an input gate. Add an output gate. An echo component. And another echo component. And then wire them up. For this demo, to keep things simple, I'm going to ignore errors. I like to make the lines a little bit thicker. We save it. Meta S will do it, and the pull down will do it. Then we go to the command line and run make. We see the output from the run. There's a single message, hello world, on the port empty, which is stood in. Now let's make this parallel. Drag that down to here. Get rid of that line. There. Go to there. Drag that to the middle. Make all of these look nicer. And we'll make them rounded. And there it is. Now we'll save it. We'll go back to the console and run make again. And we get two outputs. Hello world on one, hello world on the other, both to the same output. What's going on underneath the hood? Draw.io saves diagrams in XML format. We use an XML parser to inhale the XML and to exhale only the semantically interesting information as JSON. I'm working on doing this with OhmJS instead of using an XML parser library. Then we inhale the JSON, create a dictionary of templates, instantiate the system and run it. I'm working on a variation that transpiles the system into raw Python. Practical example. This diagram contains the niggly details for implementing T2T, text-to-text transpilation. The first parser transpiles RWR code into JavaScript and feeds it to the second parser. OhmMeta2 was developed at VPRI for creating many DSLs. OhmJS is a descendant of OhmMeta2. Text-to-text transpilation is so simple that it doesn't need the full power of even OhmJS. The end. DOS and 0D ideas are being used in production by Kagi.com.
Very cool. Yeah. So we have about 6.5 minutes for questions. I have a couple, but if anybody else has some, I'll let them start. Feel free to just speak up or like raise your hand and wave a whole bunch if you have something. Okay, well, absent anyone else asking questions, I've got a ton because this is like visual programming language. That is my jam. I'm extremely here for it. And then you snuck in at the very end that it's like, oh yeah, this perhaps obviates the need for something like Ohm. It's even simpler than that. That's um, a surprising thing to me, and it relates to something earlier. You said you showed the big map of sort of here are all of the clusters of ideas that um, could be brought to bear in how we're going to revision programming, but you're just going to focus on 0D and the diagrams as syntax. But then at the end, you talk a little bit about text to text. So what do you see as the difference between or the interest in text to text versus this diagram as syntax? Like, what's the relationship going on between those two?
It's a bunch of things put together. I think one of the things is this 0D, this strong decoupling. As soon as you can decouple bits of software, then you can escape and free your mind to imagine other types of things. I'm interested in concurrency, so node and arrow are sort of natural fallouts of that interest. Text to text is, I'm also interested in building compilers, and compilers are really just text transformers if you really look at it. And it turns out that, I got interested in Ohm.js because I was interested in parsing. Peg parsing is more powerful than CFG parsing. I believe in generating code, so Peg falls more into that mentality than so Peg feels like a parser generator to me rather than a language specifier. Where was I going with this?
Or if I could
Yeah,
shape the question a little bit, which is it fair to say that the 0D idea, this extreme decoupling, like that allows you to take part of a system and say this part of the system is most naturally expressible in a node, an arrow, visual syntax because it's doing something concurrent, whereas this other part of the system might be more naturally expressible in a certain text language, in a DSL or something like that. And so the text to text would let you take that or set up that DSL for that part of a system and transform the result, and then take this node arrow and transform the result, and then get pieces you can glue together. Is that kind of the vision for that part?
Yeah, it's sort of going towards Lego blocks.
Yeah.
So what we seem to be doing is figuring out more and more complicated APIs, and I think we need less and less complicated APIs, like Lego blocks, which is just round holes in square, or round pegs into square holes, or whatever it is. I've got grandkids, so I was looking at Legos. So what we want to do is snap pieces of software together, and we want to be able to choose whatever syntax or diagram or whatever it is that we want, that is most suited to the way we're thinking about this aspect of the problem. So for example, I've used Prolog a lot, and I think Prolog is essentially overblown. It does one thing really well, which is exhaustive search, and stuff like even JavaScript does formatting better than Prolog does. It's hard to think of formatting done in Prolog. You can, but it's sort of a waste of brain power to figure it out. So somewhere like a year or two ago, I just had a thing where I did exhaustive search and I did formatting, and I wrote a little DSL that joined Prolog-ish syntax with JavaScript-ish syntax, produced two shell scripts, or produced a shell script that ran a Prolog program, piped it into a JavaScript program, and produced the result. Is that going in the direction you're asking? Yeah.
I mean, I'm mostly just asking for more color on how you envision the relationship between these ideas, which I think you spoke to quite nicely.
Yeah, the ideal would be to have a Unix shell, which is diagrammatic, like a DPL, kind of like a node and arrow thing instead of bash, and to feel free to use it without thinking that you're using big heavy duty processes and MMUs and all that stuff. I'd rather throw away the MMU and have 1,000 CPUs with their own bits of memory on them, on a chip, rather than all the stuff that we're wasting chip real estate on.
Yeah.
And what do we need more than 1024 bytes of memory for it anyway?
Yeah.
Per CPU, per actor, or hundreds of bytes. You think of a Radio Shack calculator, it's got what? 4 to 10 save locations for numbers. And that's really all that a normal human needs. We like to think about programming, but normal humans do some calculations and put aside some of the results somewhere. Sometimes they print it out on paper. Sometimes they hit save and recall and that sort of thing. And that's what we should be doing when we present it to non-programmers. I think of my dentist. He went to university. He uses computers, but he's not into it the way I am. So I know how to use a QWERTY keyboard better than he does. So what? Yeah.
I think I'll take this moment to call time. There's a thing you said in there that I'm desperately itching to dig into, but we can take it to the Slack. And about that claim of well, what would we use this memory for? And it's like, I see a couple things you're doing that could benefit from more memory per CPU than that, but that's a can of worms. Paul, thank you very much for the presentation. That was a very interesting summary of your work, and I'm excited to see more of that map get explored, and you share your findings in all those areas. Michael, who's up next?
Denny, and I can try to pronounce your last name, but I will
Feel
not.
free to try.
Vrandečić.
That's very good. There we go. It's not that hard. Vrandečić, yes, indeed.
Nice.
So let's see if I can share my screen or if my system will tell me that I don't have permissions. Yay. Do you see
Looks
my
good.
screen?
Yeah.
Very good. Hi, I'm Denny Vrandečić. I'm working for the Wikimedia Foundation that you may know from websites like Wikipedia or Wikidata and similar. And we recently started a new website called Wikifunctions. And the idea of Wikifunctions is that it's a website that is a wiki, so everyone can come in and edit it. And it's a free library of functions that you can contribute to, that you can work on. Because it's only 7 minutes, I'd run a little bit in the beginning, but I hope you'll have enough time then to catch up. So we started only end of last year, and we currently have about 1,300 functions or so in the system. It's mostly constrained by the types that we have already introduced. So we started only with Booleans and strings, and we added pretty late actually numbers and stuff like this, only a month ago or something, and so on. And people are building functions out of these. So one example, I'm starting with an intentionally very simple one in order to show the system well. So this is the AND function, like the Boolean AND function. So I can put in true and false, and I get back, hopefully, false after a while. Or if I run true, well, this is really a while. Sorry for that. It shouldn't take that long. Come on, it's not that hard. I just assume something is off right now. So it should give you, this is not great. Never do live demos. I have no idea what's good. So it should give you here the result, and you imagine it's giving you the result and it's telling you true and true is true, true and false is false. I have no idea why it's not working right now. With every function, users can define tests for those functions, what should be the results of those. We can have several implementations for each of the functions, and they can be in different programming languages. So, for example, the JavaScript implementation for AND is not particularly interesting. It's, well, it's taking the AND.
Right.
Python is the same thing. It's asking you for AND. What we then have is also something called composition. Composition is not a new programming language that you haven't hear about of. It's just taking existing functions and putting them together in order to get the result of this function. So in this case, for example, the AND function is implemented using the if function. It says if the first value, then return the second value, otherwise return false. This is an implementation of the AND function. You can do it in other ways too. There are like 3 or 4 implementations of the AND function in the system. And what the system then does, it runs them against a test. It looks at the average runtime behavior and selects the usually the fastest one to run.
Can
Then,
I
yes.
interrupt you here? And I have switched the time over to question time. And just to remind everybody, this is the format. You can interrupt at any time you want, and we'll switch the time over to question time instead of presenter time. Your functions are using what look like hygienic names for the function name and the arguments and that sort of thing. Can you speak very briefly about what the thinking is there?
Yes. So the actually we want to hide them here. So this is still in development. We want actually to hide and show the proper names. Every function has a Z ID and just an ID, like a Z identifier with a number. And in addition, every function has labels in different languages. So this is actually an implementation. So this is the AND function, for example, and we have 26 different labels for the AND function, which should be showing when I'm clicking here. This is not very impressive. I don't know. So basically we should have here 26 names for the AND function in different languages. Here we go, finally. And so that you can actually see the implementation in your language. So we have those set IDs which are for the internal, but we replace them then when we ever use them. So this is, for example, the composition now in English, but I can see the same thing also in German, actually. And it's the same function, because we're just replacing the names of them. So you can edit, you can view the functions in about 300 different languages that we currently support, and you can also create them in those languages. It's not because sometimes programmers don't speak English if they want to code, but most programming languages are tied into code. So this is how it basically works. So we can either compose, you can provide function implementations in different programming languages like Python. We currently support only JavaScript and Python. We want to support much more over time. And here's just a few examples of functions. Let's hope they work now. So if I want to, for example, future of code in Morse code, I would click here and then hopefully get the result. And there we go. Finally, something works. We see the future of code actually in Morse code given. Here we have implementations in Python and JavaScript. We have again tests and so on that you can see how do they pass against the implementation. The thing that we are actually working towards is a lot of natural language generation functions. So this here one is supposed to give me the superlative of an adjective. So if I run here, for like black, I should get blackest back if everything works. In this case, it did. Yay. Because the goal is actually to make those functions available from Wikipedia and the other Wikimedia projects so that you can integrate them into an article text and then also switch from one language to the other, basically, and so that you have more consistent content between the different language editions of Wikipedia. But we're not talking about this today. So we have this large catalog of functions currently. We are working on making it bigger. We're on developing a community to actually maintain those things. What you have seen with the composition is one way to represent those things. It could be here different. You could have different ways to actually represent, because it's all just, some composition. It could be also displayed in a more graphical form, as we have seen with Paul's presentation before. It could be, and you can use definitely things like using a JavaScript implementation here, connecting it with a Python implementation there, and we just use them across languages. If like parts of the composition are in one language, part of the other, it shouldn't matter at all. It should all just be able to work seamlessly. So I think this is the end of the presentation. because I wanted to have enough time for questions and quick discussion.
Great. Yeah, we have about 8 minutes left
Sweet.
for questions. Yeah, this is fascinating. So you said something very quickly in passing that I just want to make sure I understood, which is that there is a goal of this project would be to um, I'm kind of reading between the lines a little bit. Like if you have a Wikipedia article that's about some programming concept and you have code samples, the code samples wouldn't necessarily be limited to a specific programming language and a specific human language. You might be able to say, like, if it's an example of, logical um, stuff or if or something like that, you could say, like, show me an example of this in JavaScript or show me an example in Python, but German Python or French JavaScript. Is that correct? Did I understand that correctly?
That's not our goal. It's a nice
Oh,
idea,
okay.
and we probably should be able to actually do that. But the goal is more rather, we have currently parts in Wikipedia articles which are calculated based on some data. For example,
Hmm.
there could be unit conversion, or there could be the age of a person, which is being
Hmm.
calculated based on the date of birth, or how old was the person when they died, and so on. It's all calculated and displayed. And we would like to provide functions for these kind of things, and even for generating actually text out of knowledge. So we have with Wikidata for a large database of structured knowledge, and we want to use more of that in the Wikipedia articles in order, for example, for smaller language communities to provide more content of it in as text. So you can imagine a function, for example, that says the capital of Kenya is Nairobi, and
Hmm.
saying that in different languages, and generating this text in different languages based on the data in Wikidata. And then we would have the population of Nairobi and so on. So we could pull this all in and generate text for articles out of that, because in many languages, well, English is a really bad example because English is very complete, but in many languages we don't have in a large enough community to provide a current and comprehensive encyclopedia. So having this as like something that provides some basic information and generates text for it and integrates it in Wikipedia is basically the goal in order to create a more comprehensive encyclopedia in those languages. This is why we're focusing so much on natural language generation functions. If you take a look, we have here a lot of natural language generation functions for a number of languages already, about 20 of it. The community is still growing, so we're still really at the beginning. But these generate a lot of morphological functions for the different languages that we currently support.
Seems like a linguist's dream. This is extremely cool.
I hope so, yeah.
Anybody else
Thank
on the
you.
call? Questions for Denny?
Yeah, can you also run these functions from the outside? So via using an API, for example.
You can call, we have an API that you can call in order to make a function call. What we don't provide yet, but we're planning, as it's on the timeline, is that you can actually run it on your CPU. So all the code is there. You should be able to just, download the function and run it on your own hardware. So currently, yes, we have an API. You can call it and use results. We ask you not to overload us. We are still young. But it exists. But eventually, all the stuff is already running in WebAssembly in the backend. So basically, our idea is all we have to do is now ship the WebAssembly to you if you want to, and you can run it then on your own content and on your own CPU and use it as often as you want. We're not there yet. We're still working on this part. Also, we just chose the wrong programming languages for WebAssembly with JavaScript and Python. This wasn't a very smart choice.
Cool. Any other questions?
You, I think, briefly mentioned, Denny, that the site itself kind of runs the implementations, finds the fastest, and then uses that to kind of run the demos. Is that information that is there going to be like metadata information about the kind of like runtime or like efficiency of any of the different implementations at some point?
Yes, we provide
Oh,
all
awesome.
the metadata about the different implementations already, so you can just grab it and download it and so on. So this is available.
Super cool.
I had another question. Got a couple minutes left, so I'll be greedy and burn up question time.
Go for it.
So Michael asked sort of about being able to run these on our own machines. I'm interested in this as sort of like a corpus that one could potentially, when this expands large enough, use it almost to like bootstrap a standard library, or to like
Yes.
figure out, like, if you are prototyping a new language, here is a comprehensive set of things that you may want to incorporate, and it serving that role. You are nodding emphatically, so I imagine this is something you've thought about.
Yes.
Can you
I was,
talk about that for a minute?
yeah, I would love this to be like, a standard library for standard libraries.
Yeah.
Things you can just like say, if I create a new programming language, I don't really care about creating all those mathematical things. I just want to have them available because a programming language expects those. So just implement a bridge to wiki functions and be able to, like, okay, these are the functions that I want, or even say, okay, point to the set ID or whatever it is, some way to access a specific function, and you can use it from your language, which allows you to focus on the things in your language which are novel instead of the things that are happening. So the wiki functions are all functional in the strict sense that we don't have side effects. They don't change. They have no state. There's nothing happening, which means it should be easy to put it into a lot of different places. And yes, I would love this to be a library that can be widely used for all kind of things, like new programming languages, or in spreadsheets, or in tons of things.
Anywhere you need to do some computation with
Yeah.
functions, which is very many places, as I'm sure we are all well aware.
Right.
Yeah.
The biggest problems that we have is actually explaining the project, because mere mortals have troubles understanding what a function is, what you can do with it when they're useful. And even though for a lot of people, functions are super useful in their daily life, they don't see that, they don't know that, and they're like, oh yeah, this app is good and so on, but they never see the ability that you can just use your own function in doing stuff. And this is one thing that we've been struggling for 4 years, frankly, to just to explain the project. Once they see a few examples, it's like, oh, okay, now I get it for these specific domains. But then we lose them, like, but you can do it in many domains, and there's a lot of stuff, and we're still struggling with that. I hope that we can also help a little bit with the general education around these issues, but I really don't know how to capture that, how to make a dent here on this task.
On that note of yearning, it's a good time to call time on the demo. A good feeling to remind ourselves that we are all always struggling to figure out the human factors as well as the machine kind of stuff. Yeah, we still have no Conrad. Conrad's a no-show today. Yeah, Daniel.
Yeah, I'll have to quit Zoom first because I saw that I didn't give it the rights to share my screen, so I'll be back in a few
Sounds
seconds.
good.
I will use these few seconds as a chance to invite you all to come to wikifunctions.org. Play around with it, give it a ride, try it out, join the community if you want to. We're still in a very limited number of types. It's still sitting there there's tons of stuff that doesn't work, but it's all open source, as you would have expected from the foundation and so on. So please come by, give us a try out, and there's so much stuff that I think can be built on top of this.
Yeah, what comes to mind as you've described, so basically what we're looking at is kind of a wikified, we have functions are a more structured data type than, say, articles in Wikipedia. It's that a function is a thing that you would want to talk about, and it has and functions as a rule have these extra qualities that make them functions versus any other bit of information. And so it makes me wonder if the same kind of thing that you're doing with function is in terms of I have a wiki of structured data, whether it would apply to other things. The first things that comes to mind are locations, where a place has places as such have particular bits of metadata that are common to things that are places tend to have this, and this information about them that is structured. versus versus just, you know, plain text about someone talking about a place. And I feel
Yeah,
there's some common element to any kind of structured data. And so there's nothing special about functions per se, except they're things that run on your computer. There's all sorts of glue that seems like it would be common to any structured data type, where it's, well, all things of this type have these extra bits of structure beyond just a plain text that describes them.
yeah. If I may point you
How
to
has
my
this
previous, yeah, if I may point you to my previous
come
project,
up?
we have wikidata.org, which actually has a lot of structured data about locations and basically everything that has a Wikipedia article and many more things. This is exactly, I think, the idea that we were trying to do there. That's a very lively project. It's very large. It's about 100 million items. It's actually editing faster than Wikipedia and has a pretty large community with several 10,000 people. I never thought that, you know, a structured data project on the web would get more than 500,000 contributors, but it did. So wikidata.org is, I think, exactly that. And we have a Sparkle endpoint where you can query the data in the system, where you can get a lot of outputs of that. And the idea with Wikifunctions is also that we will actually connect to Wikidata as a background knowledge phase, so that you can also ask questions like, did Tyrannosaurus Rex live together with Brachiosaurus or not? And it will look in Wikidata, what's that information? When did they live? Does this mean that they live together? And then answer you the questions and stuff like this. So the functions can operate on this knowledge base of data that is in there in Wikidata. But Wikidata is also something you can just go ahead and use yourself. A lot of people are doing the Google Knowledge Graph, Siri, all of these things are based on Wikidata and are using that.
I'm going
Yeah,
to
so I guess a
step in as
question.
moderator and say, I know that William's
I'll do it.
question was about what is a more fundamental thing that sits underneath structured data and structured functions, and say that I'm allergic to category theory and we will not be discussing anything about that on this call today. Apologies, William. Daniel, you're back. I
Yes,
assume you've appeased the Zoom gods. They're happy
I
with your
hope so.
blood and data sacrifice.
Let's hope.
Yeah, let's see if
I'll try to share my screen.
yeah. And if that fails for some reason, then we can talk about foundations. Yeah.
It's very slow, but I'm getting to it. Okay.
Yeah, cool. And we have a mysterious gray rectangle that started screen sharing.
Okay.
There we go. We see resheet data.
Nice. Okay.
Should we be seeing your mouse cursor?
Yes.
We do.
You should.
Yes, we do see your mouse cursor. Great. Cool.
So,
yeah, go right ahead.
Yeah. Resheet is a personal project of mine. It is a general purpose notes and calculations tool, where I tried to build something as flexible and extensible as possible, and having a very small core, which supports all of that. Yeah, and this is my current attempt to the current state. So you see here, this is resheet itself. It's not how it's looking. Oh man, how it's looking typically. You have, it's very similar to Notion in the looks, and it has elements of a spreadsheet. That's why I call it a notes spreadsheet hybrid. So you can just type your notes and you can start formulas with an equals, like in any spreadsheet, and you can use JavaScript in there to run calculations. So I'll give this a name and I can do some calculations with JavaScript. So the interesting thing is, okay, I have here lines here and I can use blocks in every line. So let me add a new page. So yeah, this is my demo. And I can use, for example, a code block to do some multi-line calculations, whatever, something like that. So, okay, you get the idea. So, or I can use something like the load file block to load some files. So that's just for my personal use. No, it's not just for my personal use cases, but these were things why I did this. So I can load files and use them and do stuff with them. Okay, so for example, one little thing, just to show you what things I see one could do with this is once I had a saved document, a saved resheet document that was getting huge and I didn't know where this came from. So I wrote this little thing where I load the file itself. So this huge file, 25 megabytes. Yeah, everything gets calculated. It's very slow with screen sharing. Yeah, and I can use React libraries to, for example, here, create a diagram. So what I did here is I just show the keys of some of the object that I loaded and how big they are, and I could drill down by that which part was getting so big. So, okay, I saw here in json.inner.pages and so on. Yeah, zero and so on. Yeah. So where the problem came from. That's the basic usage of resheet. And the more interesting stuff, I think, is you can build your own blocks in this. So here you can just, so here you're using blocks that are already part of resheet, like a node block, sorry. But you can, for example, it doesn't have a block for picking dates or something like that. So I can import some library from npm.js. I'm using ismsh for that to get some UI for that, and then just build a small wrapper around of that. And I have this date block now, which I just created by typing this here. Sorry, block. So, and here is the block. Oh, I'm sorry. Yeah, and now I can use the value from this thing and do something with that. And if I change it here, you can see here below that the value of the date updates. Okay. Yeah, and all of resheet, all of that you see here in resheet, you can use inside your custom blocks. So, or inside your sheets. For example, at the end here, I show that I can embed the whole resheet thing in itself and use that just as a fun little thing here to show how flexible and modular this is itself. Yeah, and the last part is showing some other interesting things for example, this interactive game dev thing I did. So I built a custom block here that is named game. It's not very large. It's this thing. It's mostly just plugging stuff together. It's more boilerplate than logic itself. And with that, I can do an animation or a game, building a game, and see live how everything is calculated. So I have an initial state that I specify for the game. I have a render function below here that I just hide, and I have this update state code, which is a sheet itself, and I can run it and see how it updates very slowly now with screen sharing. Normally this runs smooth. And yeah, I did this up to running a real game. So having some simulation itself, how gravity is affecting the character and how input should affect the state. So yeah. And yeah, that's basically it. And I think the time should be up for my demo.
You pretty much exactly nailed the time. I let you run like a minute over because felt like you were wrapping up. Nicely done. Well paced. I've got a bunch of questions, but once again, I'll turn it over to the peanut gallery. No. Anybody questions?
Well, of course, the first natural follow-up question for anyone seeing this is, okay, we've seen other notebook interfaces before, like Wolfram notebooks or Jupyter notebooks, and what made you, what do you feel you're bringing to that topic with this? I mean, this is like, I have my own thoughts on this. It's pretty darn awesome. But what motivated you to have Resheet in the first place?
That's an interesting story, and I don't think it's very enlightening. The thing is, I had something else in mind at the beginning when I started this, and it somehow morphed into this direction. And now I'm here, and I saw, oh, this is very similar to all these other tools. But still, the difference is mostly the extensibility, I think. So building your own custom blocks, what I see in here is you don't have to, so one thing is you don't need to have JavaScript code. You could write a block which does something else and compiles to a WebAssembly and runs this in WebAssembly. Or you could have another interface, a block which has a for programming and integrating this with the rest of Resheet. And if you're doing it good, you could even also embed other Resheet blocks in your graphical programming environment itself again. So the idea was to build this very flexible core of putting blocks together to be able to build some kind of programming environment, something like that. It's not programming only. So I have also the focus of doing information in that. But that's the idea.
A question I have
super
is
cool.
Comparison between this and other tools, which feels like, there's going to be a couple questions around that because this is a well-explored space. And so it's, but they're not super ubiquitous. So it's kind of cool to unpack, like, what are the, all the different subtle permutations in that idea space. One of the things you've got is what seems like very nice attention to layout and typography. Like looking at what we're seeing on screen right here, the way that you're showing inline values, like they're readable, but they're small so that they're easy to kind of overlook. They're not fighting against the actual statement of the variable. And you've got, sort of literate programming style descriptions of what each of these variables are. It's very nice looking, and I'm curious if you've been tempted to like feed some of that into the sort of the Reacty, JavaScripty actual programming parts, like, make that a little bit more rich text, or is that just for the sort of, some of the rendered views of these blocks? I guess the question is generally like, what are your thoughts on like typography and rich text and that sort of thing in the programming of this?
Yeah, so this thing itself, I mean, the idea was to have some note-taking tool and be able to make calculations in that. And by choosing JavaScript, and I wanted to have something that's powerful, it got to the state that it's even possible to build anything with that. So it was a natural focus to do this, to focus also on typography and the UI design and stuff like that. When I started to focus a lot on that, I had a much more rough prototype of this, and I put a lot of time first into polishing the UI and getting it to look nice before adding new features. And yeah, that's the current state. It's much time went into really making sure that this also looks nice.
Cool. And if people want to use this, is there a live version?
Right. Oh yes, of course. It's just resheet.dev. Oh, and you just saw the landing page and all of the content that's here, so you can fiddle around with it yourself.
Very cool.
I have a question. Have you also been exploring running parts of Resheet in other applications, so that you build something with Resheet and use it in a regular React application, for example?
It should be possible. So the question is, what exactly do you want? Do you want to have the full Resheet interface just embedded somewhere? That's totally possible, even though I didn't take the time to make a library out of it to be able to use it. But the code itself is currently mostly a library and just some little code that I use to plug everything together to create this website. Yeah, but if you just wanted to use the result of something you built with Resheet, that's not so easy because it's very convoluted how it's calculated, how these sheets are calculated. So yeah. Does this answer your question?
Yeah, I was wondering if you could use the parts that you created with Resheet externally. I think that would be very powerful.
So of which parts are you talking?
Well, anything you create with this.
Okay.
I can imagine, part of and maybe you have an invoice calculator as an example, but that you use that.
Yeah, it's not so easy. So you could use this whole sheet itself. Yeah, that's easily possible. If you just want to show this, you could build a sheet that hides everything else. So this would be possible, but it would still run the whole sheet infrastructure in the back.
Cool. That brings us to the end of our time. Thank you to our 3 presenters today. Three seems like a good amount because we can get it done in an hour
It does.
and have a bit of time for hiccups and transitions and stuff. So I feel like, yeah, maybe
Yeah.
for the next one, try and get 3 demos. Yeah, I'm just gonna hit stop recording. Boing.
I will
Yes.